Assalamu alaikum students and good morning. Last time we studied current and then magnetism. Now we are going to merge electricity and magnetism and we get a new field of science or field of study, and that is known as electromagnetism. Let me share the objectives of today's topic. By the end of the lesson you should be able to define electromagnetism, use right hand rule to predict the direction of magnetic field in a current carrying wire. You should be able to draw a magnetic field around a current carrying wire using compass. Draw magnetic field around current carrying flat coil. Draw magnetic field pattern around current carrying solenoid. Before defining electromagnetism, there is a story of Oersted, and that is like accidentally discovery. In 1820, Oersted discovered accidentally in his class that a magnetic field is produced around a current carrying wire. In this way, a new field of study was born, and that was electromagnetism. That is, he was demonstrating something, and there was a wire on the table, and nearby the wire there was a compass. In the wire, current was passing. He observed that the compass needle is deflecting, and from this he discovered that when current passes through a wire, magnetic field is produced, because the compass will deflect if there is a magnetic field. So the study of magnetic effects produced due to current carrying wire and the applications of this magnetic field is known as what? Electromagnetism. It means that when current passes through a wire, magnetic field is produced around it, and this study is known as electromagnetism. And from this word electromagnetism, we can see there are two parts, electro as well as magnetism. So you can say that magnetism due to electricity is what? Electromagnetism. When current passes through a wire, magnetic field is produced around it. The direction of magnetic field is either clockwise or anti-clockwise. It is observed in experiments. Near the wire, magnetic field is strong, and moving away from it, it gets weaker and weaker. When large amount of current passes through the wire, strong magnetic field is produced, and vice versa. It means when the current is larger, then the magnetic field will be stronger around a wire, and if the current is smaller, then the magnetic field is weak. There is a small experiment, and the purpose of this experiment is to draw magnetic field pattern around current carrying wire. So the objective of this experiment is to draw magnetic field pattern when current passes through a wire. The apparatus needed for this are cardboard, wire, EMF source or cell or battery, pencil and compass. These are the steps. Suppose that there is a cardboard, there is a small hole in it, and there is a wire passed in it, and suppose that current is passed in the wire in this direction. Let me take pen. Suppose that this is the direction of current in the wire. So definitely, conventionally, this end will be connected with positive and this end will be connected with negative terminal of the battery or cell. So the current is passing up or moving up. Now suppose that here is a compass placed, and the compass needle is deflecting in this direction, for example. So this is the tip of the compass, this is the tail of the compass. So here, take cardboard, make hole in it and pass wire in it. Connect both ends of the wire with terminals of cell or battery. Put compass on cardboard near the wire and observe the direction of deflection of the needle. So suppose that this is the direction of deflection of the needle. Mark the tail with dot A. Assume that here I put a dot and I name it A. So this is A, and here I put a dot and I name it B. Now what we do? Now move the compass in such a way that the south is on B. So this is the north side and this is the south. Now move the compass, bring it here, for example. Bring it here, and now we will observe that here this is the south end and this will be the north. Now assume that the compass is reflecting in this direction. So when it is reflecting in this direction, this end was B, and so this end will be C. And now move again the compass. Suppose I bring the compass here. Now we will observe that the compass is reflecting in this direction. So this end is C, while this end will be D. Suppose this dot is dot D. We need dots. Now we move the compass here, for example, and we observe this direction. And here, over here, it is reflecting in this direction. So we have, in this way we will get dots, and when we join the dots we get a circle, and in this circle the needle was pointing in this direction. So we get a circle like here. Suppose this circle around the wire, and this circle is in this direction, and we know that this is known as anti-clock. So here, now move the compass in such a way that the south is on B and north and new direction of the tip. This is known as tip, while that is tail. And in this way put dots. Join the dots, we get a circle. Repeat the experiment from different lengths. Now suppose that I put compass here, and then I put a compass here, similarly here, and over there, little bit far away. So we will get new circle, and this circle will be a little bigger, and in this way another circle, and so on. So we can get what? Circles around wire. Now the observations obtained from this experiment, that the magnetic field produced around a current carrying wire consists of concentric circles. Near the wire, these circles are found closer, and away from the wire they are little apart from each other. Means suppose this is the wire and this is the direction of current in it. So the first circle is, for example, here, then the second circle is a little bit closer to this, but the third one is a little away as compared to the first two, which shows something. This shows that when you move away from the wire, the magnetic field decreases, or the strength of the field decreases. This gap is more, while this gap is less. So here the magnetic field is stronger, while here the magnetic field is weaker. You can say that, suppose that I take this distance from the wire, and similarly this is also the distance from the wire. When you move away from the wire, the magnetic field decreases. When you come closer to the wire, the magnetic field increases. So you can say that the strength of magnetic field is inversely proportional from the distance from a wire, and vice versa. Now if this is the direction of current in a wire, then the how I will be able to find out that what is the direction of the magnetic field. Here it is either clockwise or anti-clockwise. The same as the case here. How I can find out that what is the direction of magnetic field? So definitely I will put compasses here experimentally, but if I am theoretically asked, then what I will do? I will use a rule, and that rule is known as right hand grab rule. And that rule says that pretend that you are holding the wire in your right hand in such a way that your thumb is pointing in this direction, then the curling of fingers will show the direction of magnetic field. So if you pretend that your ballpoint is a wire and you hold it in your hand like this, that the thumb is pointing in this direction, then your fingers will curl in this direction. So this will be the direction of the magnetic field. So the curling of fingers, it shows the direction of magnetic field, and that is anti-clockwise. But if you hold the ballpoint like this, that your thumb is pointing downward, then the curling of fingers will be in this direction, and the direction becomes clockwise. So here the magnetic field is clockwise. This is suppose your ballpoint and you are holding it in such a way that the thumb is pointing in the downward direction, means you are indicating that the current in this wire is going down. Then observe your curling of fingers, it will be like this, and that shows what? The magnetic field clockwise. So this is the answer to the previous question, that how I can find out the direction of magnetic field, that by using right hand grip rule. According to this rule, grip the current carrying wire in your right hand in such a way that thumb is pointed in the direction of current in a wire, then curling our fingers show the direction of magnetic field. So remember, this is very important rule. Now it's the turn of magnetic field pattern around a flat coil. What is flat coil? Suppose that here is a wire and the wire is passed in a cardboard like this. This becomes what? This is known as coil. It is having a single turn. And now assume that this side of the battery is plus and this side is minus. So this is the direction of current in a wire. So here the current in a wire is up and here the current in a wire is down. And we know that when the current is moving up, the magnetic field pattern is anti-clockwise. So here I am going to make anti-clockwise magnetic field. Here will be another circle. So here is another circle and then another circle and so on. So here will be a magnetic field in this direction. Now over here the current is going down. When the current is going down previously we saw that the magnetic field will be clockwise. So it will be like this. The magnetic field is clockwise. So it is like this. If you continue to draw circles, so it will be like this. And you will observe that in between the two wires, the magnetic field lines are in the same direction. That is, for this it is anti-clockwise, for this it is clockwise. But in the middle, you see, the directions are in the same. It means that when the direction of the magnetic lines are same, here we will get a stronger magnetic field between the wires, while here it will be weaker as compared to here, because here we will have magnetic field lines only due to this, while here we will have magnetic field lines only due to this, while in the center they are sharing their strengths. So in the center the magnetic field will be very strong. You can consider it like a tunnel, and consider that in the tunnel a river is flowing from that side to this side. So this river indicates what? A magnetic field, and this is the magnetic field pattern. This is observed in this experiment, that when current is increased in the coil, the strength of the field increases and vice versa. In the center of the coil, field lines are closer to each other and are in the same direction, which shows that in center magnetic field is strong and uniform. Reversing the direction of the current, the field pattern also reverses, which we observed here as well. If the current is going up, the magnetic field is anti-clockwise, but when the current is down, the magnetic field is clockwise. Now there's a dot and cross phenomena, or dot and cross rule. Sometime in books or in papers they give you this pattern, that these are the circles and these circles show the magnetic field, and this dot shows that the current is flowing in a wire and that is out of the plane of paper. It means that there's a wire here and in the wire the current is going up. So they will give you this in a paper, they draw magnetic field pattern. So what you will do, you observe here that when the current is going up, then the circles are anti-clockwise. So this dot will show that there is a wire and in the wire the current is going up. So what you will do, you will just put arrows here. So these are arrows, and these arrows show what? That the direction of the magnetic field is anti-clockwise, while the cross shows that there is a wire and in the wire the magnetic field is going down. That is, the current is into the plane of paper, the current is going down here. So the magnetic field will be what? According to the right hand grip rule, it will be clockwise. So this is the magnetic field clockwise. Similarly, you observe that there is a less distance here while there is more distance here. So this shows that the field is weaker here. So this is dot and cross phenomena. Now the final thing is magnetic field pattern of solenoid. What is solenoid first? It is a wire which is wounded several times, is known as what? Solenoid. Simply you take a wire and you coil it like this, just like spring. So this is what? This is solenoid. Now this solenoid is having 4 turns in this length, for example, and while suppose that if I draw another solenoid and I draw the lines, the circles or the winding closer, then I can make more number of turns in the same length. So here we can say that there are more number of turns per unit length while there are less number of turns per unit length. It is very important phenomena. So wire wounded several times is called what? Solenoid. When current passes through a solenoid, magnetic field is also produced. Now here I made a small video for you, and you will see that how magnetic field is produced around a current carrying solenoid. Let me play it for you. So this is solenoid having 4 turns. Now I am connecting it with a cell. So the left is positive, the right is negative, and in this way the direction of current will be up. This I am drawing the direction of current now. These arrows show the direction of current. Now we know that when current passes through a wire, magnetic field is produced. These are now the magnetic field lines I am drawing. So you will observe when you do this experiment that in the center of solenoid, magnetic lines are parallel and very close to each other. And when the magnetic lines are in this manner, look at the arrows. The right side will be North Pole and the left side will be South Pole. And we know that magnetic field is always from north to south. So these are now the magnetic field lines which are from north to south. These lines are coming from the right side. This is the magnetic field pattern. This shows the direction of current. Now the magnetic field pattern of solenoid looks like a bar magnet having 2 poles, that is north and south poles. The magnetic field lines inside the solenoid are parallel and closer to each other, which means that magnetic field is stronger inside. Outside the solenoid, the field lines are curves, which means that field is weak outside. How to find out the direction of magnetic field in solenoid now? Again we use right hand grip rule, but this time using right hand rule, what you will do, we will curl the fingers in the direction of magnetic field. We will curl the fingers in the direction of current. Then the thumb will be pointing in certain direction, and that thumb will point towards North Pole. So what we say that grab solenoid in your right hand in such a way that curling of fingers show the direction of current this time. Previously, curling of fingers, they were showing the direction of magnetic field, but now curling of fingers show the direction of current. then the thumb points towards North Pole, and ultimately we can draw lines and can mention South Pole as well. Like in the video, you observed that the North Pole was on the right side and the South Pole was on the left side. What are the factors that affect magnetic field pattern in a solenoid? These are the main factors which affect the magnetic field pattern in solenoid. Magnetic field strength in solenoid can be increased by increasing current, increasing number of turns per unit length of solenoid, placing soft iron core within the solenoid. You know that soft iron concentrate magnetic field inside it. So if you place a soft iron core inside the solenoid, magnetic field will be concentrated inside the core of solenoid and stronger magnetic field will be obtained. Now let's wrap up some important or key points. We say that when current passes through a wire, magnetic field is produced. What will be the direction of magnetic field? Direction of magnetic field is found by using right hand rule or right hand grip rule. It will be either clockwise or anti-clockwise. Magnetic field is strong if magnetic lines are closer and parallel to each other, and weak when lines are curved and further apart. Torch shows current moving up in a conductor, that is out of plane of paper, the paper on which you are writing, and as a result magnetic field will be anti-clockwise. Cross shows that current is into the plane of paper and magnetic field produced will be clockwise. So this was all about today's topic. Now what you do, you open your book and study the field patterns, and especially the right hand rule for both for wire in which current is passing and solenoid, and try to draw those figures. And when you are drawing those figures, what you do, you make small videos and send me your videos. That's it for today.